We know that the air we breathe, that space which looks completely empty to our eyes, is not actually empty. But how full can it really be? Well, in 1m3 of air, you would find trillions of molecules. In fact, we could even say octillions. Of course, we don't see them. Thankfully, we don't. Otherwise, we wouldn't be able to see anything at all. But yes, we already know that the atmosphere is quite full. This might not seem very surprising. Let's leave the atmosphere, go into the vacuum of space, and take 1m3 from there and look at it instead. If you're guessing that you might catch a few atoms, let me put it this way. In what we call empty space, there are more than 10 million particles in a volume of 1m3, but all right, let's say this. We know there are countless particles coming from the sun. Cosmic rays. Could these be the reason for those millions of particles? Let's go even farther. So let's move to one of the emptiest regions of our galaxy, as far away as possible even from the nearest star. Even there in 1m3 you will find at least 100,000 particles. So where can we find emptiness? Let's leave our galaxy as well. Let's throw ourselves into intergalactic space. This time, forget the stars. Let's take 1m3 of space from a place where even galaxies don't exist and examine it. Yes, this time we can truly see only a few atoms. Over 13 billion years, galaxies have essentially swept this space clean by pulling in all the remnants. But notice this, even here you can still detect dozens of particles. So is there an even emptier place in the universe? The short answer is yes, cosmic voids. Cosmic voids. Let me give a warning in advance. If you're experiencing an existential crisis, this topic might make it even worse. Because here's the situation. There are voids and supervoids in the universe. These are the leftover empty regions after particles clustered somewhere over nearly 14 billion years and formed galaxies and galaxy groups. Some are voids, some are supervoids. These are places millions of light years across where you can find almost absolutely nothing, and there are quite a lot of them. For example, in the Boötes void, which is about 330 million light years in diameter, only around 60 galaxies have been discovered. If in one of those 60 galaxies, on any planet, a civilization ever existed, it could be one of the loneliest civilizations in the universe. But if you've started to feel sorry for that lonely civilization, I need to stop you right there. Because we, our galaxy, the Milky Way, are actually located right at the center of the largest supervoid we've discovered in the universe. Some call it the local hole, others call it the KBC void. And the local galactic neighborhood that includes our galaxy exists within a void that is about 2 billion light years in diameter. We're talking about a terrifying emptiness. Terrifying. Even if you traveled at the speed of light, it would take 2 billion years to go from one end to the other, and encountering anything along the way would be a miracle. Did something get triggered? If you feel a sense of fear, don't worry. You're not alone. You might be experiencing nihilophobia, and this is a kind of fear that can truly take many people's breath away. The fear of emptiness, the fear of being in a void, the fear of being lost in emptiness. And our universe is full of reasons that can trigger this fear. But if we return to our topic, emptiness, is a space where absolutely nothing exists truly possible, both yes and no. The answer depends on how you look at it. If by emptiness you mean a space where none of the particles we have discovered exist, then yes, a large portion of these cosmic voids consist of regions where not even a single atom can be found. But if you think of this emptiness, this lack of particles, as absolute nothingness, that's where you're mistaken. Quantum mechanics steps in once again to challenge us. When you look at a space where not a single atomic particle exists, from the right perspective and with the right instruments, you actually observe energy there. Energy coming from quantum fields. The electron field, the photon field. But wait, there were no electrons or photons in these voids, right? Yes, there are. However, even in a vacuum, even in what we call nothingness, there exists what is known as residual energy or zero-point energy. What did we say before? Space is not actually empty. And we also said that this residual energy causes quantum fluctuations. Yes, We have even been able to detect this energy of the vacuum. This is an incredible achievement for humanity. It is both terrifying and awe-inspiring. These fluctuations are also telling us something else. Because the question is simple. If there is nothing, no particles at all, how do these energy fluctuations arise? This is where we need to shift our perception. When we say there are no particles, we mean there are no particles in the classical sense. In reality, what causes these fluctuations are virtual particles. At every moment, at every Planck time, space, at this point we call nothingness, is constantly giving rise to what we call virtual particles, which cannot normally exist, appearing for a brief moment and then disappearing. They are born and die continuously. They exist and vanish constantly, every moment. And this cycle of existence and non-existence is what supplies energy to the vacuum. A continuous story of birth and death. A brief life that gives life to emptiness. So what comes next? A moment when everything ends, galaxies, stars, particles, even time itself. The universe we are currently in is expanding, and not at a constant rate, but accelerating. That means distant galaxies are not just moving away from us, they are moving away faster with each passing second. This means that one day there will be no stars left in the sky. Billions upon billions of years later, stars will have moved so far away that their light will no longer reach us, and only darkness will remain. But this is just the beginning. Because stars also die. They burn for millions or billions of years. Then they either collapse or scatter heavy elements into their surroundings as they fade. What remains of these dead stars are white dwarfs, neutron stars, or black holes. Over time, the universe will be filled more with the remnants of dead stars than with light, and eventually, they too will disappear one by one. Imagine this. When the universe reaches around 1039 years, nuclear decay will have effectively stopped. Even white dwarfs will have cooled. All matter, all energy, all information will gradually submit to the second law of thermodynamics. Entropy will increase, and it must. Because in a closed system, and the universe is exactly that, order is always destined to decay. The universe is heading toward heat death. In this scenario, there are no temperature differences left. Everything is at the same temperature. That means nothing can function anymore. Nothing can move. No process can occur. All the energy in the universe is now unusable, locked in a dead void. This is cosmic ultimate loneliness. All galaxies have drifted away, all stars have gone out, all light has vanished, and what remains is a dark emptiness. But wait, it's not over yet. Because even black holes are not eternal. According to Stephen Hawking, black holes will evaporate like ice. After around 1066 years, even the largest black holes will disappear. And what will remain? Nothing but truly nothing. No atoms, no stars, no photons, just emptiness, and perhaps a few low-energy neutrinos. Even time itself will lose meaning, because nothing will change. Time only exists if there is change. But in this universe, nothing will be left to change. So in this absolute emptiness, this universe stripped of heat, light, and matter, can there truly be nothing? Here, quantum mechanics enters the stage once again. Because it tells us that even this absolute void is not truly absolute, and quantum tunneling comes into play. Even though nothing should exist in the void at the quantum level, energy barriers can be momentarily crossed, and this tunneling can give rise to something new. A new universe emerging from nothing. Just like our universe may have been born from nothing, through a momentary crossing of an energy barrier, a quantum fluctuation. Perhaps we are the echo of another universe's death. That universe died and became a void, and from that void this universe was born. It tunneled, and here we are. But if this universe was born from a random quantum fluctuation at the moment of collapse of a previous universe, if matter, energy, and time are just a temporary instability of the void, then our existence here right now is not a necessity. Not a mistake, not a choice. Just a probability. We were afraid of emptiness at the beginning, remember. We called it nihilophobia. Perhaps what we have always instinctively known is this. That void was actually our most fundamental state. And existence is merely a brief escape from it.
Thanks so much for watching my video. I really appreciate you taking the time to be here. If you enjoyed it, don't forget to leave a like and consider subscribing. It really helps the channel grow and keeps me motivated to create more content like this. Also, if you want to be notified right away whenever I upload a new video, make sure to turn on the notification bell so you don't miss anything. Thanks again for your support, and I'll see you in the next video.